Hello, 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 you lover of the wonderful world of the Matrix. Oh, sorry, no, not that one. Rather, mathematical matrices like this. Today in the wonderful world of matrices, what we're going to do is to find and to use the determinant of a matrix. And of course, your first question is, what is a determinant? And that will be the extent of our lesson today. So for warm-up, how would you find the area of each triangle below? And if you can't find the exact, how would you find an estimate? Go ahead and pause and try that. Go. So I wonder if in this first one you use the area formula. So if you recall, the generic formula for a triangle is 1/2 base times height. So all we need to do is find out the length of the base and multiply by the base of the height and cut that in half. And clearly this one's straightforward because this is 10 and this is 5 based on this number here. So we can just substitute those values in to get 1/2 of 50 or 25 units squared. Well, what about this one over here? How would we attack this one? Well, this one's a little bit harder because if I called this the base, I still don't know the exact length right there, which I could figure it out, but I don't know it offhand. But then how would I find 90 degrees to find the height right there? So that gets a little bit more tough. So I wonder if some of us just said, well, let's go ahead and count the number of squares that we have, right? So there's 1 square there, 2 squares mostly, 3, 4, 5, 6, and this one is 7 plus a little over there, and this one is 8, maybe the rest of that one, and this one looks like half-ish, so maybe together those are 9, and maybe this one is 10-ish, and then maybe these two are 11, maybe these two here are 12, and so maybe we're going to say, well, it's about 12.5 units squared. Now, honestly, I don't have the answer right now, but what that is. But what we can do is later we're going to come back and we're going to find that area using determinants today. So, by the time you're done with this lesson, we'll be able to find the area of any triangle on a coordinate plane using our friend, the matrix. So first off, a determinant. If you had 7 tests in a class, then the average of all those tests is a single number that tells you how you are doing overall. So it takes many numbers and it turns it into one useful number. One useful number. Well, a determinant is similar to that. It's analogous to that. Is that it is a single number derived from the matrix and it's also very useful. And today we're going to see one use of that in trying to find the area of a triangle. And our next lesson, we'll see how determinants are used to find inverses. So this is how we find the determinant of a matrix. If you have a 2x2 matrix, then what you do is you are going to multiply these two together, and this is called the main diagonal, and then subtract the product of the other diagonal. AD minus BC. And again, it doesn't actually matter which direction you multiply, D times A or A times D, because the commutative property holds true there. And we're going to subtract the product of that. So it's almost like cross products, but don't confuse that. So we're going to do this by hand first, and then over here you can click or scan and see the answer using a calculator. So find the determinant here. And this is how we write it. So we can write it with a determinant, DET, and we can then write the matrix right there, 3, 2, -1, and 5. Okay? That's one way to write it. If this had a name, maybe this was A, then all we would simply do is write determinant of A, DET of A, like that. Another way to write it, and this is a little bit confusing, but you could simply just write it like this, with what looks like to be absolute value bars, and that's just determinant there. Does not mean absolute value. This means determinant. So I'm going to multiply these two, and I'm going to write that out, although you don't have to write the 3 times 5. You could just do the multiplication, and it's going to be subtracting of the other diagonal there of 2 times negative 1. Now we could have skipped that, like I said, and just jump straight to this one, 15 minus a negative 2, and in the end you get 17. So the determinant of this matrix is 17. And as I said, scan that or click there to check your work with a calculator. Now it's your turn. Please attack, kill, destroy these two problems right here by hand and by calculator. Go. So doing this one by hand, again, all we simply do is multiply these two here is 32. And then we always minus, and then we always multiply these. So negative 36, and we end up getting here a 68. Over here, how do we do this? Well, we're going to multiply those two. So if we multiply those two, we get 2 over 6. Always minus, and multiply those two. And that one gives me negative 3 over 6. And when we add those together, we get 5/6. And checking that out with a calculator, you would get the same results. So, taking it to the next level, what happens if your matrix is larger than a 2 by 2, but you have a 3 by 3? And notice here, this diagonal here and this diagonal here, well, it turns out there's other diagonals. If we skip these other numbers here, then we're losing out. Not all the numbers are part of that. So, this is how it works, it says, this is the definition right here, A1, B2, C3 plus B1, which is here, C2, and then A3 there. And then last one is C1 times A2, B3. And then we're going to repeat that process, but this time we're going to go with the other diagonals. So, best to visualize it, and I like to do it in this manner. How do we visualize it? Well, what I do is I will take this column here and write it over here, next to it. A1, A2, A3. And then we're going to do that exact same thing. We're going to take this column and we're also going to extend it out over there. So that's B1, B2, and B3. Now, what we're going to do, multiply our diagonals, this diagonal plus this diagonal plus this diagonal. So, and then we continue that, but go the other direction. The product of this plus the product of this plus the product of this. And of course, the red minus the blue is ultimately what we're doing. So let's look at that as an example here. And I'm going to start by writing my 103 as another column and the 045 in the other column. All right, now let's multiply. So this plus this product plus this product here. So again, we can do that pretty quickly. 1 times 4 times 2 is simply 8. And then we add that to the 0 times negative 1 times 3, and then the 2 times 0 times 5. So that's nice. Those drop out right there. Now we subtract the sum of the others. 3 times 4 times negative 2 is a negative 24. Next, 5 times negative 1 times 1 is negative 5. And lastly, 2 times 0 times 0 is a 0, like so. And now this simplifies, just bringing this all together. Notice that we have a double negative here and there. So we end up getting 29 plus 8. So the determinant, and if we call this one A, the determinant of A is 37. And there we go. You can scan or check out this video here to see how it's done with the calculator. Now it's your turn. Please find the determinant of this one and check your work with your calculator. So let's walk through this one once more. Again, I like to write my 1, 2, and 5 here, and 0, 4, and -1 there. So we have 1 times 4 times 3 is 12, plus 0 times 6 times 5, which is 0, and then a 3 times 2 times a -1, which is a -6. Then we're going to subtract from that the other diagonals. 5 times 4 times 3, which is 60. -1 times 6 times 1, which is -6. And 3 times 2 times 0, which is a 0. Finish this up, the double negative, or excuse me, distribute the negative there, and we get -48. And a calculator works. Proves that's true. All right, now the last thing we're going to do is find the area of a triangle using our handy dandy rule that we're going to see here. So the area of a triangle with vertices x1, y1, x2, y2, and x3, y3 is the area is 1/2 times the absolute value of the determinant of A. Where we define the determinant of A is we put 1 point here, we stack the points, and fill in with a 1. Fill in with a 1. Notice that this is a square matrix, a 3 by 3. So, let's look here. The area between the North Carolina cities of Raleigh, Durham, and Chapel Hill is called the research triangle. Use the map to determine the approximate area of the research triangle. So here's Raleigh, Durham, Chapel Hill. Okay, and this is a little bit blurry, but at least we can get some coordinates right here. So it looks as though Chapel Hill is at 0, 0. Next, Raleigh looks to be here at 15 and -7.5. And lastly, Durham is up here. Looks to be here about 4 and a 2.5. So let's create a matrix. Call it a numbers or letter. Let's call it A. So A is this matrix, and let's go ahead and put in the 0, 0. And then fill it in with a 1. And then the 4 and the 2.5 right there, and fill that in with a 1. And the last one there, 15, -7.5, and also a 1. Now to speed up the process, we're just going to plug this into our calculator and simply find the determinant of A using our calculator. -67.5. And now let's use our super secret formula where we take the absolute value and cut that in half. So that means the area of what's called research triangle is equal to 1/2 times the absolute value of -67.5. And in the end, we get approximately, or 33.75 square miles. And there we go. Please take a moment to find the area of these triangles formed from the given vertices, and use your calculator for that. And here are the final results. Now the last thing I want to show you is we're going to go back to our wonderful world of the warm-up and see if we can look at this guy here and actually find the area and see how close we actually were. So the first thing we want to do is double check that we have what our coordinates here are. So this one here looks like 1, 2, 3, 4. So it's a 3, 4. This one here is a 4, -1. And lastly here, this one's a -2, 1. So let's set that up into a matrix. Negative 2, 1, 1, 3, 4, 1, 4, negative 1, 1. Now let's find the area, or excuse me, find the determinant of that. And this determinant was actually negative 28. So now when we apply that to our handy dandy equation, take the absolute value and then cut it in half, and we get 14 units squared. And notice that my estimate was actually fairly close. But the final answer, 14 square units. And this concludes this lesson. The next lesson, we're going to look at inverses and how determinants fit in.